Mr. Vikas Jambukar. He has received his bachelor degree from Pune University in 2006 and his master's degree from Pune University in 2010. He started his career with Bosch Chassis Systems in hydraulic brakes, then joined Eaton Technologies, and later moved on to Danfoss Industries. He has research and development experience in axial piston pump and motors throughout the journey of 19 years. He is currently working as a specialist engineer in the hydrostatics division for Danfoss. I would also like to introduce Mr. Mihir Rajendra Kikale. He has received his bachelor degree from Pune University in 2013 and a master degree from BITS Pilani in 2017. He started his career with Varec Engineering, later joining Whirlpool India and subsequently Danfoss Industries. He has over 11 years of experience in the NVH and structural domain, encompassing the automotive industry, home appliance sector, as well as the mobile and industrial hydraulics industry. Currently, he is working as the lead engineer in the industrial division of Danfoss. They will be presenting a paper on the innovative approach for life cycle assessment of hydrostatic products. Please join me in welcoming them. Sorry.
Hello. Hello.
Sorry, apologies. They're going to be presenting a paper on the noise optimization for tractor and hydrostatic transmissions. Please join me in welcoming them to the stage.
Hello all, good afternoon. So today we are going to present our last two works on noise optimization for hydrostatic transmission. So overall we will cover the background, objective, approach, how we actually came to solve this problem. Then the results, we will talk more on the noise study, what we conducted on tractor level and then at HST level. And then how we optimize the HST noise to meet the tractor level requirement. And at the end, we will talk about the summary and conclusion. So first we will explain you about the hydrostatic transmission. If you look at the left side, it's a hydraulic pump. And then on the right side, it's a hydraulic motor. It is connected generally through the hoses and looped into the closed circuit system. We also supply the open circuit pump oil to this HST to replenish the oil and to maintain the lower side charge pressure. So now we are talking about all this hydraulic system integrated into one housing wherein we have both pump and motor integrated as a part, and then the end cap which has all the internal connections, and it also holds the pressure. If you look at the typical tractor transmission, so basically this hydrostatic transmission input shaft is generally connected to engine, and this basically takes the engine power, convert it into hydraulic power with the help of hydraulic pump and motor, and then the output is connected through range gears and to the wheels. So basically input power is transmitted to output wheel power through the hydrostatic transmission, and it helps to control the speed variably, means infinitely variable basically. Now if you come to objective, here we are talking mainly on the investigation of the noise at a tractor level. So how we basically capture the noise on a tractor, there are multiple sources of noise on there. We identified the causes of the noise, and then we also optimized the noise and provided the different mitigation strategies. So overall the scenario what we studied is there are two different noise generation in tractor level. First is when we suddenly press the pedal. So at that time there is different noise phenomena. And when we actually go to a continuous operation, in that case generally the pedal movement is kind of smooth. So at that time, with load and without load, there are two different noise characteristics. So all these three noise characteristics we have studied in detail. So when we come to the sources of noise, now there are multiple sources, but the major sources are basically engine. In hydrostat, there are again pump and motor. Both behaves differently in noise. Then the charge pump or the auxiliary pump, cooling fan, which is actually basically cooling the tractor through the radiator arrangement. Then the gearbox or the range gears, structural parts, and most importantly, the pedal mechanism, which actually drives or transfer the human pedal force to tractor movement. Now I will hand over to Mihir to explain the approach.
Thank you, Vikas. Okay, so let's look at the approach what we have followed to kind of analyze the scenarios and come around with the mitigation strategies. So a systematic approach was followed, which included like setting up the test cases, conducting operator ear sound level measurements, filtering the data, analyzing it, interpretation, and then deriving mitigation strategies based on the results what we have found. In the OEL level measurements were taken at the operator ear using a handheld sound level device, which is class 1, and the measurements were taken in a free field condition as the AI standard prescribes. In the loading, multiple loading cases were evaluated, and the data set was around like 70 load cases. So we could not like we had filtered out 11 load cases out of that, and detailed analysis was done on this. So in the data processing, like signal calibration, time to frequency domain conversion was conducted. And in the data analysis, like we had used the ordered analysis technique. We'll be delving it in deeper. And all of these results were kind of collated to get a sound source heat map for all of the conditions. And based on that, the interpretations were drawn and the mitigation strategies were derived. So now let's move to the conditions, like two conditions, major conditions which Vikas mentioned. One was at the sudden paddle press condition. So in this case, multiple load cases were evaluated, which included a combination of tractor engine speed, the gear selection. These were typically at no load condition and when the tractor was stationary, and it was kind of accelerated, and the rate of paddle press was monitored. So this is a case where we can see this is a case for high gear and low tractor engine speed was set, and the measurements were taken along with the sound level measurements. We had also taken measurements for the port pressures and the engine RPM. So here you can clearly see, like, due to sudden pressure movements, there is a sudden surcharge of the load requirement from the HST that is seen evident in the port pressure A, and there's a clear spike. So this is like based on the sudden input, there is a high demand on the engine for the load, but the engine is not able to meet that, and the engine engine is lugging down, and it is going well below the idling RPM, which is inducing very high torsional vibrations, and the entire proto assembly was kind of vibrating and generating noise. And this is the event. You can see this is like in the time scale, and this is the frequency. This is the acoustic energy. So this is the event over there. And you can see a case like you have broadband energy content, which signifies like multiple impact event rattle events which was happening. So to address this, two actions were taken. One was adding dampeners to restrict the sudden pedal press movement, and second was optimizing the governing mechanism of the engine so that it can cater to the sudden demands of the load. So, and after this changes, you can see clearly that the peak pressure, though it has reduced, and the high, even with that load, the engine is not lugging down, and the levels were seen to like significantly reduce. So this was one case. So in this case, what was studied, like selecting the optimum gear and engine speed, and governing mechanism is critical if you want to reduce the exposure to noise. So the next case is like in the continuous operation condition. Now in continuous operation conditions, we have two cases. One is in the loaded condition, and second is in the no load condition. Like each of these have been kind of analyzed separately because as per the requirement, homologation requirements, it has different requirements. Like no load, it is like 86 decibels exposure it should not exceed 86 decibels. For loaded condition, it is 90 decibels. These are the EU requirements. So we have kind of arranged the data in such a case, like the cases where we have the OSPL levels were exceeding or met. So from this, we can identify some high-level trends. So the trends what were observed was, like typically higher gears coupled with higher engine RPMs and high engine loads were resulting to higher exposure to the operator ear levels. Second was, if you see at the loaded condition, one peculiar observation was at half pumped displacement. Like the swash paddle was not completely pressed. We were seeing like high levels of noise exposure compared to the same conditions with full paddle press procedure. So one of the hypotheses was this could be due to additional degrees of freedom being available, and which is leading to swash dither. So this will be investigated further, like in this. So out of these cases, 11 cases were identified based on the different load conditions, tractor gear combinations, and a detailed analysis was done. So we'll look into one of the case over there. So okay. So in the continuous operation, this is a case, particularly this is a loaded condition. Case with high load condition as half swash displacement. So to do our detailed analysis, we use a technique called order analysis. So order analysis is typically a technique used to characterize the vibration and noise sources for reciprocating or rotational machineries. So like we at a tractor level, we have multiple noise sources, and each of the source will have its characteristic signature, sound signature. So in order analysis, what we will try to do, like we will identify orders to the individual frequency component, and based on the sound signature, we'll map those to those particular sound source. So in this case, most of the things were automated, like I would say semi-automated, like the signal was calibrated, then the time to frequency domain was done. And this spectral data was then fed into a MATLAB script which would identify the peaks based on the prominence ratios and rank them based on the measured levels for those peaks. And to the left, you can see there is a table which is ranking the levels. Now this input was was fed into an automated macro-based Excel template which we had developed, which characterized the orders were calculated based on the source inputs, like the engine type of engine, the gear pump, the number of pistons in the HST unit, and so on. So these levels were, or the sound levels were mapped to the subsequent sources. And to the extreme right, you can see this is the visual representation of the table what we are seeing. So these levels were mapped, and this is the spectrum. So we have multiple sources, and the peaks have been mapped to the corresponding orders. So you can see in this case particularly, the HST pump orders were dominant, typically 18th and so on. Over there. Then we also had, this is a peculiar case, like where the HST motor RPMs were also closer to the HST pump, and we could see some interaction effect of that. And we also identified some coinciding orders. So those are shown in with the cyan, where actual, due to the gear pair and the combinations, the orders of different sources were coinciding. So similar analysis was done for the 11 cases, and a heat map of the sound sources was plotted. And we can see like some patterns or trends emerge from this. Like the first two cases are no load condition. In no load condition, there was some unknown source, and the orders of like HST pump was also present. Then the charge pump was there, and engine or combustion order were also significant contributors over there. So they were equally significant. So no clear dominant source was identified. But in case of the loaded condition, the scenario is changing. The HST pump, we can see clearly, the HST pump was dominating the dominant noise source, And in that, it was the 18th order of the HST pump. So this is a summary of like what I just explained, like the no load conditions we could not find, get and clear where. And so if any connective action is to be taken, all three needs to be addressed. Mitigation strategies need to be developed in combination. For HST, for loaded condition, HST pump was the dominant. And in that also the 18th pump was, 18th order was dominant, which is typically linked to the swash dither. So based on this finding, mitigation strategies were derived. Now there are two, like one is at a component level and second is at the application level. Component level was to address the HST level noise, where we are tackling the noise at the source itself. So reducing the excitation energy going into the system, that is at the HST level. There we will be talking about the wall plate optimization. Vikas will explain in detail. At application level, some mitigation strategies are like decoupling the orders, like using a pump with an odd number of gear pair so that this interaction can be reduced. Then we also see like the linkage mechanism will also have, the 18th order is linked to the linkage mechanism. So if linkage mechanism is rigid enough and if we reduce the transmission of vibration to the surrounding subsystems, the interactions effect can be reduced. So the second level, application levels, mitigation strategies are being jointly worked with the tractor manufacturer. Now Vikas will take you through the component level.
So overall, till now we discussed about the tractor level noise study, and the outcome is basically there is a swash dither in the HST, which actually creates very high peak-to-peak movements, and that rattles the linkages and create the noise. Now if you look the base wall plate to new wall plate, we have optimized the notches basically and the kidneys such that it will basically tackle the two cases. One is very high swash peak-to-peak movements, and second one is pressure rise rate inside the rotating kit chamber. So the plots here on the left side is basically baseline wall plate, and on the right side it's optimized wall plate. In most of the cases, you can see we have optimized those two values more than 40 to 50%. And the reduction basically suggests that there will be a noise level reduction. And this is proven in the theory that higher the swash peak-to-peak movements and higher the pressure rise rate means higher noise. So with this optimization, we have also need to look that when we actually optimize, so there will be impact on the volumetric efficiency as well as the mean swash movement. So volumetric efficiency loss is straight away lost to our manufacturer, and mean movements is actually affecting the pedal force. So with this optimization, we are able to reduce the noise more than 3 dB. And overall, in the conclusion, we have divided it into two levels. One is at hydrostat transmission level. So with hydrostat transmission level, with the wall plate optimization, we have almost reduced the noise level more than 3 dB. And we have also looked into the volumetric efficiency, which we try to have an impact less than 5% and swash movement less than 20%. Now, if we come to the system level or the tractor level, there are 4 scenarios. First is about the structural resonance. So that actually links with our swash linkage and HST. Then there is engine governing characteristics and incorporating the dampener into the pedal. That actually impacts the noise level, or it helps to reduce the noise level. And overall, there is a isolation possible with the help of dampening in the linkage spring and additional dampener provision. And we also need to look into the airborne noise, means when it is getting transmitted from HST to operator rear noise level. So is there any opening passages which we can close and avoid the impact on the noise? Yeah, thank you. Any questions?
Hello.
Yeah.
Can you hear me?
Yes.
I am S. Biswas from Delhi. I've been in the hydraulic field for about 5 decades. And during the 80s, I was the face for Danfoss hydraulics in India. This presentation is really intriguing for me because in the days that we worked with Danfoss hydraulics, I will just tell you a small incident. Where we had a conference in Danfoss, Notebook, the headquarters of Danfoss. And on the way back, I stopped at Danfoss, France. And they said, Mr. Biswas, if you want to increase your sales of hydraulics, then you have to apply the hydrostatic steering to all tractors in India. I came back and we tried our level best, but the industry was so cost conscious that I still remember the figure. The figure came to over 12,000 rupees for adding a cylinder and a hydrostatic steering unit and so. And most of the tractor manufacturers, they just refused to look at it. Now I'm surprised that at this level, we are talking of HST in tractors, and not only that, we are looking at the noise level of the tractor. I really don't know what is the percentage of HST being introduced in tractors in India. Can you tell me?
In India, right now, we are just in the proto phase, but we are exporting a lot of tractors from India to global, particularly US and Europe.
So that is where your study is more relevant. You are working for the Euro market.
Right.
I was very amazed to see that you are trying to, you see, we all know tractors are engine-based and they make their typical noise and nobody seems to mind in India. So for me, it was a very strange, if you had given a presentation on the introduction of hydrostatic steering, hydrostatic transmission for tractors, maybe you can do it next time. It will be more relevant, I would say.
Yeah. 2 years back, actually, I gave the complete HST for India presentation in FPSI.
But the penetration will be now about how much, 10% or 15%, do you think? Hydrostatically driven tractors in India.
In India, right now, no. Yeah.
Let me help them out. Basically, in their paper, they have very clearly indicated that this entire exercise is for the export market.
Yeah.
And the noise level also is a restriction from the, I think, EC norm. So that's what indicated in the paper, but somehow they forgot to add that in the slide.
Okay.
I think it clarifies your requirement.
Now I understand what
Yeah,
is
thank you.
emphasis on noise. Okay, thank you.
Thank you.
Okay, we will take only one more question. And this is another announcement for the speakers. The time given for the paper is 20 minutes and 5 minutes for question and answer. So please try to complete your presentation in 20 minutes and take questions. The counter shows 25 minutes. Please don't go by that because 20 minutes is your presentation so that we can take 3-4 questions.
So I am Ravinder from...
No, I have not.
I think there is a gentleman who's got a mic. Please ask a question.
Yeah, so I am Ravinder from Epiroc, Nasik. So you mentioned that you did some modifications with port plate designs. So can you tell me a little bit about that? What kind of pre-compression and decompression chambers you made? So it is basically a pre-compression to case or pre-compression to suction. And similarly, what happens to the decompression during the movement of pistons? Yeah.
Right. So basically, in hydrostatic transmission, it is high pressure region to low pressure or charge pressure region. So we have to look into both high compression to low and low to high. And particularly, this noise is impacted when we actually rising the pressure from low to high. So if the rise rate is very high, at that time it actually generates the noise. So basically, kind of in the suction to delivery side, when we build the pressure.
Okay, so you basically drain the oil in order to basically eliminate any surge of pressure between when piston moves from suction to the pressure side. So you are draining that oil to case drain chamber or to the suction side?
To suction side.
To suction side.
Yeah.
Okay.
So basically leaking the high pressure oil to suction side.
Yeah.
Maybe 300 bar to 20 bar, something like
Some
that.
manufacturers also do, they leak into the case. So
Yeah, that also possible, but when we leak into case, it generally creates a lot of heat into the case because we are basically dissipating the heat from 300 bar to like 1 bar. So very high heat generation possible. When we go to suction side, there is always a cooling provided in the hydrostatic transmission that helps to lower the temperature.
Okay. This session is basically on AI and robotics. So I'm sure if you use AI, you will get some more answers than what he has given. So I think...
I think last one question.
Yeah, one last
I think
question.
if you are getting much deeper into specific questions, I think it's better take
You can
offline.
ask him offline.
Okay.
Okay, thank you. Thanks.
Thank you.
So one more question, last question he was asking. This gentleman, sorry.
I just wanted to know that sound level between the gear transmission and the hydrostatic transmission comparison.
Okay, sound level, yeah, you can go ahead.
Okay. Yeah, so that comparison we have not showed. Like typically, we expect the mechanical transmission to be a bit quieter, but it is not necessarily the case, because what is being done in this case, the mechanical transmission was directly replaced into hydrostatic transmission. If you want to modify it into a hydrodynamic transmission, you will need to adopt some modifications in your design so that the design can be like more rigid at that, because hydrostatic transmissions will have a different spectrum of vibration energies getting induced. So in this case, the case was like the gear transmission was around 2 decibels quieter, the mechanical transmission. But that is where this work intends to, like it was not just the hydraulic transmission. We have to also address at the system level to make those adaptations suit the HST based tractors. You cannot just simply replace the HST gear transmission into HST.
Apologies to interrupt. I think we'll have to move on to the
Do you have the plan
next
to
session.
implement it in India?
Yes.
Thank you.
We'll take this off stage, I think. So we'll move on. Thank you very much,
Thank you.
Mr.
Thank you.
Vikas and Mr. Mihir.
Thank you.
Please hold on. Vikas. There's a small memento from FPSI.
I think we have to give them a big hand for having done a wonderful work. And most important is they have reduced their paper of 19 pages into few slides, I think, and without missing any content. Thank you, Vikas and Mihir.